Hello, my name is Angelique Leonard, and today I will be talking about how drought affects both plants and the insects that eat them for Hydrology and Climate at UC Merced in the fall of 2020. So, we of course want to know what the issue is, and it has been shown that in times of drought, plant eating insects overwhelm communities and prey upon plants at a higher rate than average. So, looking at both the drought stress on plants and the drought stress on insects, we want to know how these things are differing. So, first on the plant side, we realize that drought stress on plants is a negative thing and that it's going to lower nutrient levels and meaning that plant can't sustain itself. And if this plant cannot sustain itself, it will or can eventually die. It also will be lowering defenses, and with lower defenses means that predators cannot be deterred as easily as they once were, and and in this case, the predator is this new influx of plant-eating insects. So with lower defenses, it can't signal that it is bad or it's trying to look bad to these insects, and therefore they will continue to eat and herbivorize these plants. On top of that, one of maybe the most important things is that there will be less offspring, and that would lower the fecundity of the plant. With this, there will be useful traits that won't be able to be passed down, which in turn can cause their traits to become more minimal, and insects will want to herbivorize even more if drought stress continues or if drought stress comes back. All of this in total creates a higher death rate for these species or families of plants that are being herbivorized at a higher rate than previously. Drought stress on insects, however, is way more of a positive effect. So, with this, there are more plants with lower defenses, and if there are more plants with lower defenses, plant eating insects are going to be benefiting from this because defensives are down, but volume is still up. Along with this, the only negative thing is that plants, these dying plants and these plants that are being affected by drought stress have less nutritional value, but still carry over some leftover nutrients. So volume needs to be up with insects to maintain their energy, yet there will be plenty of defenseless or low defense plants to herbivorize. So previous researchers believed that insects that are attracted to plants during drought stress would increase continually as stress increases, but it has actually been shown that progress is far less linear, which also makes it harder to find solutions because if there is no pattern to their eating habits, it is harder to figure out when and how things need to change in the ecosystem, whether it is human intervention or over time. So, with all of this information, we know that there is a problem, but we want to know, on the other hand, how big is the problem and why is it so bad in the ecosystems that both these plants and these insects are in. So, it lowers the biodiversity. When lowering the biodiversity, you're ruining the chances of communal interactions. Insects like to target one species or family within the same characteristics just because that falls within their niche of what they would like to eat. In turn, with ruining ecosystems, it can also have local endangerment or extinction rates for the plants being eaten. It's been shown that colonies of insects can wipe out an area before plants have time to recover or before they have time to reach out their offspring to get more trait variability. It also lowers the diversity of traits of that given species, again leading to inbreeding, which can cause the plant to not live as long and to not have the viability of offspring. The imbalance of resources that become prevalent in the ecosystem are shown because other herbivores or omnivores that rely on these plants that are being eaten in a higher abundance by these insects are dying. And the overuse of a single plant or an underuse of the others means that plants will be fighting for resources. When there is a large amount of insects that once were in proportion to the surroundings, the plants don't have the time to create these defense mechanisms, especially in a drought. Overall, we want to know what can be done. If nothing can be done, then there's no point in doing the research, of course. But with what can be done, naturally, we think about what can the plant do for itself to repair or to change how these insects are coming about it. So we all know that these plants have defense mechanisms. There are many different types. Outwardly, there are thorns, and these thorns help insects not go onto them because it's sharp, painful, just physical pain. There's also bark, which creates a layer between the tissues on the inside and what's on the outside, so it makes it harder for certain insects to get in and to get the nutrient that they want from the plant. We also have chemical signaling, to where a plant can tell other plants or parts of itself within its root system that it is being herbivorized and that things need to shut down and they need to adjust how they're giving the resources. And also poison. So poison can be ingested and then it kills these insects, and that can eventually run down and make the insects know, let's not eat this one because we are dying. But we all know also that sometimes natural defenses aren't enough to deter predators. So we have to think what can be done after the fact. On top of natural plant defenses, there's also self-repair within ecosystems and within plants themselves. So for a normal terrestrial ecosystem, there is environment and then there is life. To get from environment to life, there's consumption, and from life to environment, there needs to be restoration mechanisms within the food chain. If there aren't restoration mechanisms, or if there is a sudden change in different species that are affecting this ecosystem negatively, then this can't happen. So self-repair, one thing could be resource partitioning. Natural resource partitioning can occur over time. That lets these insects kind of eat what they would like and also allows for other herbivores to eat too, and also the plants to regenerate within a timing that works for them. So another thing is ecosystem adaptation. That means that these plants are naturally overcompensating their offspring to add more of a chance of their eventual survival over time, and having these offspring at different times, either later or earlier in the season, to account for drought can have a better understanding of them and giving them more of a chance for survival. There's also the option of leaf shedding, and shedding their leaves means that they are keeping their inner vascular tissue intact and hoping that these plant-eating insects will go for the leaves and they have a better chance or a longer chance to survive than if they did not shed their leaves. Another slight option could be having human intervention. While human intervention is very minimal and can only be minimal in these scenarios because this is an occurrence happening in different ecosystems all over the world, this can help on a smaller scale by helping plant drought-resistant plants in areas of residential places or in areas where drought stress is constant or happens every so often that you realize that there's a pattern. There's also the option to keep moisture in these areas where there are plants that may not be able to work around drought as easy as other ones for both residential and crops to help mitigate insect species in and around homes and in and around the food that we and livestock eat. Having open space laws on top of that can leave room for the natural regulation that we just spoke about. And leaving room for natural regulation means that humans don't need to intervene and that these species of plants can help themselves over time. So, in conclusion, what is not so great is that there's not much that can be done by humans to mitigate this, meaning we kind of need to stay away from it, even though we can recognize it as a problem. When letting the area repair itself, it leaves much more room for it to happen over time and gradually at a pace that plants and insects can both adapt to. Adding in humans can create these extra problems, add to the workload that just, again, will cause a spiral effect and could make things worse off than they once were. There is a potential of moving plant-eating species, but again, we know that anything that we do to this ecosystem can have consequences deeper than the underlying one. There does need to be, however, more research on non-harmful or minimally invasive treatments. So doing this means that we can have human intervention to potentially let these problems go away quicker than they naturally would have if humans did not intervene.